Okay, I was going to do one more Anova example to help. So here's my question. Let me make it a little bit bigger. Oops. Okay, 4 sororities took a random sample of sisters regarding their grade means for the past term. The results are shown in the table below. Okay, so here are some means of sorority sisters of their average grades. So it says using a significance level of 1%, is there a difference in mean grades among the sororities? So what they're trying to see is, do they all usually score the same? Are there differences? So I went ahead and I made my hypotheses. So my null is that the mean of sorority 1 equals the mean of sorority 2 equals the mean of sorority 3 equals the mean of sorority 4. My alternative is that now all the means are equal. So my next question is get my F distribution. And the way I'm going to do that is I'm going to go, let me go ahead and, oops, let me do this. Let me minimize this. Let me go ahead to the one-way Anova calculator. Okay. So I have 4 sororities, so that means my number of treatment groups is 4. And each of these had 5 data points in each group, so I'm going to put 5. So I'm going to continue. If you want to find the data, it's on page 708 in the book. All right, so these are mean grades by sorority. Okay. Okay, so I'm just going to put 1, 2, I'm going to save myself some time, 3, 4. Okay. So here I go. For the first sorority, I'm just going to put in the average grades based on what I found in the book. That's all I'm doing here. Okay, and then okay. Oops. So I have all the grades in there, and I want to display the graph, so I hit compute. All right, so let's look at the box plots. All right, so these are they look kind of different. There looks like there's some below and some above, so I'm not really sure what's going on here. So what's really important to me is my degrees of freedom for my treatment and my errors, my F value and my P value. Okay, so let me go back. So I need to go ahead and do my F distribution. So remember, it's going to be F, which is 3, 16. Where am I getting those numbers again? So if I go back to my website, 3 is right here, and then 16 is right there. So that's where that comes from. You don't even have to do anything from hand. Okay, then let's go back to my PowerPoint, and then it asks, what is your F statistic? So what is my F statistic? All I do is go back. My F statistic is 2.2303. So I'm going to put 2.2303. I just caution you, if it says 2 decimal places, just put 2.23. Okay, now it wants me to do the probability statement. So that is going to be p-value equals probability of F is greater than 2.2303, and that's going to equal just the p-value. And what's my p-value? It's 0.1241. And where did I get that? Right here. There's my p-value. So next step, it wants to know, it wants me to conclude this. So I'm going to compare, let me go down here. remember let's do this. Let's go on to another page. Let's go to here. Okay, so I'm going to compare P and level of significance. Okay, so my p-value was 0.1241, and I'm going to compare that to 0.01 because that was my level of significance. This is not smaller. My p is not smaller. It's actually larger. So I cannot reject the null hypothesis. So what does that mean? It means I'm going to keep it. So if I go back here, it means keep it where the means are the same. So even though if we go back and look at this picture, even though they look slightly different, they're really basically the same. There's no huge difference in these. Okay, so then I need to conclude. So I'm going to say there is sufficient evidence to conclude that there is a difference among the mean grades for the sororities. Oops. All I have to write. Okay, so what did I find out? I found out that none of the grades are really that different based on sororities. And that's how you do another example.